A winner in the new economy. I just identified two groups that are poised to thrive and that I claim are accessible. Those who can work creatively with intelligent machines and those who are stars in their field. What's the secret to landing in these lucrative sectors of the widening digital divide? I argue that the following two core abilities are crucial. Two core abilities for thriving in the new economy. 1. The ability to quickly master hard things. 2. The ability to produce at an elite level, in terms of both quality and speed. Let's begin with the first ability. To start, we must remember that we've been spoiled by the intuitive and drop-dead simple user experience of many consumer-facing technologies, like Twitter and the iPhone. These examples, however, are consumer products, not serious tools. Most of the intelligent machines driving the great restructuring are significantly more complex to understand and master. Consider Nate Silver, our earlier example of someone who thrives by working well with complicated technology. If we dive deeper into his methodology, we discover that generating data-driven election forecasts is not as easy as typing, "Who will win more votes?" into a search box. He instead maintains a large database of poll results, thousands of polls from more than 250 pollsters, that he feeds into Stata, a popular statistical analysis system produced by a company called Stata Corp. These are not easy tools to master. Here, for example, is the type of command you need to understand to work with a modern database like Silver uses. Create view cities as select name, population, altitude from capitals union select name, population, altitude from non-capitals. Databases of this type are interrogated in a language called SQL. You send them commands like the one shown here to interact with their stored information. Understanding how to manipulate these databases is subtle. The example command, for example, creates a view, a virtual database table that pulls together data from multiple existing tables, and that can then be addressed by the SQL commands like a standard table. When to create views and how to do so well is a tricky question, one of many that you must understand and master to tease reasonable results out of real-world databases. Sticking with our Nate Silver case study, consider the other technology he relies on, Stata. This is a powerful tool, and definitely not something you can learn intuitively after some modest tinkering. Here, for example, is a description of the features added to the most recent version of this software. Stata 13 adds many new features such as treatment effects, multi-level GLM, power and sample size, generalized SEM, forecasting, effect sizes, project manager, long strings and blobs, and much more. Silver uses this complex software, with its generalized SEM and blobs, to build intricate models with interlocking parts, multiple regressions, conducted on custom parameters, which are then referenced as custom weights used in probabilistic expressions, and so on. The point of providing these details is to emphasize that intelligent machines are complicated and hard to master. To join the group of those who can work well with these machines, therefore, requires that you hone your ability to master hard things. And because these technologies change rapidly, this process of mastering hard things never ends. You must be able to do it quickly, again and again. This ability to learn hard things quickly, of course, isn't just necessary for working well with intelligent machines. It also plays a key role in the attempt to become a superstar in just about any field, even those that have little to do with technology. To become a world-class yoga instructor, for example, requires that you master an increasingly complex set of physical skills. To excel in a particular area of medicine, to give another example, requires that you be able to quickly master the latest research on relevant procedures. To summarize these observations more succinctly, if you can't learn, you can't thrive. Now consider the second core ability from the list shown earlier, producing at an elite level. If you want to become a superstar, mastering the relevant skills is necessary, but not sufficient. You must then transform that latent potential into tangible results that people value. Many developers, for example, can program computers well, but David Hansen, our example superstar from earlier, leveraged this ability to produce Ruby on Rails, the project that made his reputation. Ruby on Rails required Hansen to push his current skills to their limit and produce unambiguously valuable and concrete results. This ability to produce also applies to those looking to master intelligent machines. It wasn't enough for Nate Silver to learn how to manipulate large data sets and run statistical analyses. He needed to then show that he could use this skill to tease information from these machines that a large audience cared about. Silver worked with many stats geeks during his days at Baseball Prospectus, but it was Silver alone who put in the effort to adapt these skills to the new and more lucrative territory of election forecasting. This provides another general observation for joining the ranks of winners in our economy. If you don't produce, you won't thrive, no matter how skilled or talented you are. Having established two abilities that are fundamental to getting ahead in our new, technology-disrupted world, we can now ask the obvious follow-up question: how does one cultivate these core abilities? It's here that we arrive at a central thesis of this book. The two core abilities just described depend on your ability to perform deep work. If you haven't mastered this foundational skill, you'll struggle to learn hard things or produce at an elite level. The dependence of these abilities on deep work isn't immediately obvious. It requires a closer look at the science of learning, concentration, and productivity. The sections ahead provide this closer look, and by doing so will help this connection between deep work and economic success shift for you from unexpected to unimpeachable. Deep work helps you quickly learn hard things. Let your mind become a lens, thanks to the converging rays of attention. Let your soul be all intent on whatever it is that is established in your mind as a dominant, wholly absorbing idea. This advice comes from Antonin Dalmace Sertalanges, a Dominican friar and professor of moral philosophy, who during the early part of the 20th century penned a slim but influential volume titled The Intellectual Life. Sertalanges wrote the book as a guide to the development and deepening of the mind, for those called to make a living in the world of ideas. Throughout The Intellectual Life, Sertalanges recognizes the necessity of mastering complicated material and helps prepare the reader for this challenge. For this reason, his book proves useful in our quest to better understand how people quickly master hard, cognitive skills. To understand Sertalanges' advice, let's return to the quote from earlier. In these words, which are echoed in many forms in The Intellectual Life, Sertalanges argues that to advance your understanding of your field you must tackle the relevant topics systematically, allowing your converging rays of attention to uncover the truth latent in each. In other words, he teaches, to learn requires intense concentration. This idea turns out to be ahead of its time. In reflecting on the life of the mind in the 1920s, Sertalanges uncovered a fact about mastering cognitively demanding tasks that would take academia another 7 decades to formalize. This task of formalization began in earnest in the 1970s, when a branch of psychology, sometimes called performance psychology, began to systematically explore what separates experts, in many different fields, from everyone else. In the early 1990s, Anders Ericsson, a professor at Florida State University, pulled together these strands into a single coherent answer, consistent with the growing research literature, that he gave a punchy name: deliberate practice. Ericsson opens his seminal paper on the topic with a powerful claim. We deny that these differences, between expert performers and normal adults, are immutable. Instead, we argue that the differences between expert performers and normal adults reflect a lifelong period of deliberate effort to improve performance in a specific domain. American culture, in particular, loves the storyline of the prodigy. Do you know how easy this is for me? Matt Damon's character famously cries in the movie Good Will Hunting as he makes quick work of proofs that stymie the world's top mathematicians. The line of research promoted by Ericsson, and now widely accepted, with caveats, destabilizes these myths. To master a cognitively demanding task requires this specific form of practice. There are few exceptions made for natural talent. On this point too, Sertalanges seems to have been ahead of his time, arguing in The Intellectual Life, men of genius themselves were great only by bringing all their power to bear on the point on which they had decided to show their full measure. Ericsson couldn't have said it better. This brings us to the question of what deliberate practice actually requires. Its core components are usually identified as follows. 1. Your attention is focused tightly on a specific skill you're trying to improve or an idea you're trying to master. 2. You receive feedback so you can correct your approach to keep your attention exactly where it's most productive. The first component is of particular importance to our discussion, as it emphasizes that deliberate practice cannot exist alongside distraction, and that it instead requires uninterrupted concentration. As psychologists, Erikson and the other researchers in his field are not interested in why deliberate practice works. They're just identifying it as an effective behavior. In the intervening decades since Erikson's first major papers on the topic, however, neuroscientists have been exploring the physical mechanisms that drive people's improvements on hard tasks. As the journalist Daniel Coyle surveys in his 2009 book, The Talent Code, these scientists increasingly believe the answer includes myelin, a layer of fatty tissue that grows around neurons, acting like an insulator that allows the cells to fire faster and cleaner. To understand the role of myelin in improvement, keep in mind that skills, be they intellectual or physical, eventually reduce down to brain circuits. This new science of performance argues that you get better at a skill as you develop more myelin around the relevant neurons, allowing the corresponding circuit to fire more effortlessly and effectively. To be great at something is to be well myelinated. This understanding is important because it provides a neurological foundation for why deliberate practice works. By focusing intensely on a specific skill, you're forcing the specific relevant circuit to fire, again and again, in isolation. This repetitive use of a specific circuit triggers cells called oligodendrocytes to begin wrapping layers of myelin around the neurons in the circuits, effectively cementing the skill. The reason, therefore, why it's important to focus intensely on the task at hand while avoiding distraction is because this is the only way to isolate the relevant neural circuit enough to trigger useful myelination. By contrast, if you're trying to learn a complex new skill, say, SQL database management, in a state of low concentration, perhaps you also have your Facebook feed open, you're firing too many circuits simultaneously and haphazardly to isolate the group of neurons you actually want to strengthen. In the century that has passed since Antonin Dalmais-sur-Delanges first wrote about using the mind like a lens to focus rays of attention, we have advanced from this elevated metaphor to a decidedly less poetic explanation expressed in terms of oligodendrocyte cells. But this sequence of thinking about thinking points to an inescapable conclusion. To learn hard things quickly, you must focus intensely without distraction. To learn, in other words, is an act of deep work. If you're comfortable going deep, you'll be comfortable mastering the increasingly complex systems and skills needed to thrive in our economy. If you instead remain one of the many for whom depth is uncomfortable and distraction ubiquitous, you shouldn't expect these systems and skills to come easily to you.